Hey guys, what do we think about this statement? This statement says all teachers at Fairlead are women. Is this statement true or false? Yes, you're right. This statement is false. And we know that because if we walk around the school and look in every single classroom, we would stick our head in Mr. Blair's classroom and see that he is a teacher at Fairlead and he is a man. So Mr. Blair proves that this statement is false. This statement is a conjecture. It's an unproven statement based on observation. So if you came into Fairlead and you never came out to the trailers and you just walked around and looked in all the classrooms, you might think, oh yes, all the teachers at Fairlead are women. And you might make that conjecture, which is an unproven statement based on observation. However, Mr. Blair is what we call a counterexample. And that is because he is an example that proves a conjecture false. So pointing out that Mr. Blair is a teacher at Fairlead and he's a male is a counterexample. It proves our conjecture false. So let's do some more examples of conjectures and then seeing if they're true or false and using a counterexample to prove them false. Here's a conjecture. It says, if a shape has four sides, then the shape is a square. Okay, so first we want to think, is that true or false? And when we're thinking about whether it's true or false, we could try to think of some examples that might prove it false. And one thing that I think could prove it false would be like a rectangle, right? So if I draw this shape here, this is a shape that has four sides, but it is not a square. It's a rectangle. So we're going to say this is false, and the counterexample would be a rectangle. There are other counterexamples. A rhombus would be a counterexample. A trapezoid would be a counterexample. So those are all shapes that have four sides, but they're not squares. So that's a counterexample. Let's try another one. How about this one? If x squared is odd, then n is odd. Okay, so let's think about this for a second. X squared would be the result of squaring a number. So let's think about some numbers that are perfect squares. 1 is a perfect square because that's 1 times 1. 4 is a perfect square because that's 2 times 2. 9 is 3 times 3. 16 is 4 times 4. 25 is 5 times 5. 36 is 6 times 6. 49 is 7 times 7. So that's a pretty good list of perfect squares. So let's see which ones are odd. The odd ones are 1, 9, 25, and 49. So let's think about what numbers we have to square to get those. This one is 1 squared. This one is 3 squared. This one is 5 squared. And this one is 7 squared. So it looks like anytime we got an odd x squared, the original number that we squared was odd. So I think this one is actually true. I can't find a counterexample that proves it false. There's no counterexample, so we can say that through inductive reasoning that it's true. Let's try another one. This one says, if x squared equals 64, then x equals 8. So let's think about that. Let's try this out. If I do 8 squared, that does equal 64. So now I need to think, okay, well, are there any other numbers where if I square it, I would get 64? Well, how about negative 8? If I do negative 8 times negative 8, that does equal 64 because a negative times a negative is a positive. So I'm going to say this conjecture is false. And a counterexample would be negative 8 because negative 8 squared equals 64 also. So x doesn't have to be 8. X could equal negative 8, right? Okay, so that's the whole idea behind a counterexample. Counterexamples are just one or more examples that can prove a conjecture false.